So hi, this video will show you how you can configure the temperature using a signal timer, right? Or their output. Okay, basically you need to do the same thing. Use the temperature probe and connect to the target. Sorry, to the device. We need to set the temperature. Okay, and now in the probe we need to set the low value to 0. Extremely important to put 0 here. Will help you a lot. Help you a lot. Okay, and up value here we need to set a value, a maximum value. So this instrument can select this temperature between 0 and 200s. Okay, so for example, you need to set this to 300s. You need to put here. Okay, so my maximum temperature, I put this 200s. Okay, it's fine for me. And let's connect a PID here. Okay, and you need to connect the negative side. This is the sensor side. Okay, and the positive here, this positive sign, you need to put the output device. So I use the timer. You can use a signal processor and what you want. Okay, the last thing is connect the right. Sorry, the last thing is connect the this is a white square. So we need to connect this to my furnace. So basically, this is the throttle. And let's put this, and I have this data log here to show you one important thing. Okay, is basically set up. Okay, is basically built. Is there, and let's configure the probe. This is so. For example, I need to set this guy here to be 18 degrees. Okay, to be 18 degrees. So need to get my target temperature and divide it by 200s. 200 is my maximum temperature here. So if you have 300 here, divided by 200s. Okay. So 18 divided by, sorry, by 200s, I give you for 0.4, and this is equal to 15. Oh, sorry, 14%. Okay, let's set here, and how we can see this is stop to warm up, but the last thing you need to configure and this depend on your system. Okay, so this tiny system here don't work with this configuration here. If you click it, you can set these variables here. You have the KD, the KA, and KP. I don't recommend you to mess with this one, or just use the KP. Oh, okay, so the KP itself is like an aggressive setting. So if you put a value here, a bigger one, this will make the PID more aggressive. So now the temperature is 15. No, sorry, 5, and I don't know how to say that, but basically this temperature is not reaching the 18 my target, so this needs to be more aggressive. So I test the system with 15 and it works very well. So we need to try and test UE1 system. Okay, so like magic now is getting very close to my target. Okay, now we can see here, and the magic of the system, this tiny system here, is different to the older one. Okay, I send it for you, and this you can set the temperature, the target temperature, use the probe. So if you put here 15%, this will set to 100 degrees here. So it's basically half of the maximum. The maximum is 200, so you'll be set to 100. And I can set for example, let's use 7, 115 and divided by 200. This will give me 16%. Okay, 16%. Let's set here, and the target temperature is 150. And how you can see, it's getting very close there. And the last thing is, if you put a KP too low, let's just cool down this a tiny. If you put a KP too low, you black. If you put a KP too low, you basically never will reach the temperature, target temperature. And if you put a too high value, now you have some oscillations behavior. We can see here, it's nothing, it's not stopped, it's not static, it's moving because of this. How you can see here, you have a oscillation behavior. So the oscillation with time will be lower and lower and lower, but how you can see, we have this behavior here. So you probably set a value too high to the use system. It's high, yeah. Well, that's probably 50-50 is better. And now, how you can see, you have a tiny oscillation and this converge to a value. Now it's stopped and the temperature you reach target. And basically, is the system. The advantage, you can control your target temperature. Okay, so if put a turbine here, if put a cable and turbine, you can using this control set the temperature here. Basically, you have a very dynamic system. So thanks for watching.